Hello guys, welcome back, and today we will talk about TensorFlow, a few more operations. So TensorFlow is not initially finished. We have a lot of operations. There are more than 300 or 400 operations are there, but we are going to cover those operations initially, which is very much important to start our deep learning model training. So I'm going to teach you about the basic operation on TensorFlow. So the on the same sheet which I had created last time, on which I'm doing my coding, I'm using that sheet only, and I will put everything over there. I will put all the codes there, and I will also provide you the link of that sheet so you guys can get the sheet and can do practice along with the sheet by taking the reference of that sheet. So anyways, guys, let's move to Google Colab sheet. So guys, we are in the sheet now. So today we will talk about basic tensor operations. The title of this video should be the basic tensor operation, where we'll learn about create tensor using NumPy library, addition operation, subtraction operation, multiplication, element wise. What is element wise? I will let you know, because multiplication are of two type in matrix or array. Division element wise, I will also teach you how to divide elements of tensors. Okay, so this is division operation, element wise, matrix multiplication. So these six concepts I will cover in this video, so I'll go through one by one. So first of all, we will create two tensor. So I'm going to cover the very first topic, like I'm going to create tensor using NumPy. So NumPy also provide us to create array, right? Our array is called tensor. So to import NumPy, I have to simply use import NumPy as NP. If you don't know about NumPy, I would recommend you to go to my machine learning tutorial. There I have explained about NumPy from start to end. So you will get a good hands-on experience of NumPy if you'll go through my Python playlist video. Or if you'll find in my playlist section of AI Martians, so you will definitely get all kind of playlist of related video of NumPy. So I'm going to simply import NumPy as NP, because I'm mentioning NP here because I don't want to use NumPy each and every time while performing any operation. So I just want a small name, and that's why I mentioned NumPy. You can put anything, like I just want to use small name NumPy. You can take any name like NK or K or Krishna, anything you can use. Okay, so I'm going to simply use NumPy. Let me zoom in the screen. NP. Okay, so I just want to create two tensor or two array. So let's create it. Creating two tensor or array using NumPy, and then we will convert it into tensor using TF. Okay, TensorFlow. So first of all, I'm going to create two array using NumPy. So A is equal to NP dot array. In NP, in NumPy, there is a class called array, okay, using which we can create a array. We have to simply pass a Python list over there. So to not make it much complicated, I'm keeping simple values. Let's say 1, 2, 3, 4, 5 once again. And I want to create one more array. So NP dot array. One more thing, keep in mind while doing any kind of multiplication, addition, subtraction kind of operation, you have to keep one thing in mind, that array dimension should be same. And what is dimension? I explained in earlier video. Please go through it and you will definitely aware about it. All right, so I'm just taking few more examples. 5, so 4, 3, 2, 1, let's say. Just to make it simple, I just use sequential value. There is no such kind of restriction. So you can take any kind of random value. Okay? So I will print the very first array, print A, which will give me an array. So this is that array which I used to create using NumPy. So it is 1, 2, 3, 4, 5 kind of element it contains. So second one is print B. I want to see both the arrays, whether it is created properly or not. That's why I'm printing it simply. So what I have to do, I have to convert it into tensor, because this is right now in NumPy. If you will print the type of A or B, anyone out of these two, it will simply give you it is created using NumPy. See, class numpy.nd array, because it is created by the help of NumPy library, and that's why it is mentioning like that. So Now I want to convert it into tensor. So casting the numpy array into tensor using TensorFlow library. One more thing, guys, it is not different. It is same, okay? But the only thing, because we learned about TensorFlow, so I am simply converting it into TensorFlow kind of stuff. So TensorFlow would understand about it, okay? Because we are learning about TensorFlow. So how can we convert it? So first I need that library. Which library? TensorFlow library. Import TensorFlow as TF, shift enter, and I think there's some mistake. Tensor, I missed N. TensorFlow. Yeah, I can get it. TensorFlow, I'm able to import it now. See, and I want to convert this array A and B into tensor. Okay, so TF dot constant I'm using. I told you what is constant in the last video. Please go through it. The whole playlist, you will get idea about it. So I have to simply pass A, and I'm storing it inside a variable called X. Okay. Print the value of X, you will get tensor this time. See, tf.tensor 1, 2, 3, 4, 5, shape is 5 because there are 5 elements inside this tensor. So that's why it is mentioned 5. And the counting of values inside it is 1. Means how many elements are there inside this parenthesis? So 1. That means it has one dimension. If you will not understand by this, you can simply check the initial brackets, okay, used by the tensor. So there is only one bracket, that means it is one dimension. So either using number of count of values inside this tuple, which is assigned to shape, you can assume this is one dimension, or you can simply count the initial bracket of that tensor. Okay, so you will get aware with it, like what are the dimension of these. Okay, and data type is int 64. Okay, int 64 data type is here. So I also want to convert b into tensor, and I'm assigning it to a variable called y. Okay, and if I will print this, I will get two tensor this time. The first one is this, and the second one is this. Okay, so just to get the idea, like I'm talking about x, I'm just putting here in a string x comma and y. Okay, comma y. So I'll get at the end, like this is x conversion and this is y conversion. Okay, means I convert a to a tensor. I can simply mention a and b. So I use two tensor. Okay, a and b. I convert a into tensor called 1, 2, 3, 4, 5 assigned to a variable called x. Okay, and this is b. I convert it into tensor and assign to variable y. So I mention here b colon y. Okay, so b get converted into tensor. So I'm getting value 5, 4, 3, 2, 1, and its shape is also 5 because there are 5 element, and its dimension is 1 because initially it has one bracket, a square bracket. Similarly, in shape parenthesis, there is only one element. That's why it is called one dimension. Okay, so now I want to scroll up. The second operation what I have to do is addition. I want to add these two tensor. Okay, these two tensor, what, x and y. Okay, so I'm just printing the value of x and printing the value of y. Okay, so this is my x, this is my y. If you want to make it more clear, you have to simply assign x string in front of that x or y string in front of y. See, so you will get aware with this. So this is x tensor, this is y tensor. Okay, now I want to add these two values. I want to add this one to this tensor. Okay, so I will get 6, 2 to this. So 2 plus 4 will become 6. 3 plus 3 becomes 6. 4 plus 2 becomes 6. Okay, 5 plus 1 become 6. Okay, so I will add these two, and the shape will be 5 comma, means one dimension, and there should be 5 element, because after adding these two values, 1 second, let me show you. So let's say if I'm adding this and this, okay, I will get 6 comma. If I will add these two, I will get another 6. If I will add these two, I will get 6. If I will add these two, I will get 6. If I will add these two, I will get 6. And because we are doing addition operation on one dimension matrix, so it will simply return me one dimension, means one bracket at both the end. Okay, and it will give me shape equal to 5 comma. So data type would be also same, that is int 64, some sort of array I will get. Okay, so let's do this addition operation. So I'm going to do addition operation on this. Okay, this operation I'm going to perform on these two tensor. Okay, so let's do it. Here I will mention tf dot shift space bar. If I will press after putting dot or a, I will get add operation there. See, there is add operation. I will put a parenthesis there, and I will pass any number of tensor. Okay, but their dimension should be same, means each tensor should have 5 element. Okay, and one dimension. Each tensor I have right now have 5 elements and one dimension. So I will simply pass x comma y, and I will assign to a variable called, let's say, tensor addition. I just want to make it readable. That's why I am putting here like a readable name, tensor addition. If I will print tensor addition, shift enter, I will get 6 as mentioned earlier. So see, if I will add these two value, it will return me 6. If I will add these two value, it will return again a 6. If I will add these two value, it will return 6. If I will add these two value, it will return 6. And similarly like this, it will return 6. And look the shape, because each shape has equal number of element and one dimension. So I will get the same shape here as well. The D type, yeah, or data type, you can say D type means data type. Okay, so D type is int64 in both cases. So once I will add these two values to tensor, I will get a single tensor whose data type would also be same. Okay, so there is no change. So this is how we do addition operation. Now let's move to the second operation. So second operation is subtraction. Let me check. Yes, it is subtraction. So let's do this. So I'm doing operation on the same on these two array only. So let me copy this, and I will mention here 2.3 subtraction. Okay, let me make a heading, and I will put this two variable once again. So because I'm going to do subtraction on the same. So the subtraction means what? I will subtract two values, right? So I will subtract this to this. So 1 minus 5 will be minus 4. I will subtract 2 minus 4. It will give me minus 2. Okay. If I'll subtract these two, 3 minus 3, I will get 0. If I'll subtract these two, 4 minus 2, I will get 2. If I will subtract 1 from 5, I will get minus 4. Okay. So I will get one array or tensor which contain such kind of value which are looking at your screen. So this is not minus, this is basically plus. I'm sorry, this is my bad. I will get this tensor this time. Okay. So how I will get it? So if I will subtract x minus y, then only I will get it. Okay. So let's see how can we do this. So I'm simply putting subtraction operation here. So tf dot let me check subtract. I'm getting subtract there. So I'll simply mention x comma y. Always keep in mind both arrays which we have of one dimension and they also have 5 elements. Elements should be same, dimension should be same. Always keep in mind before doing such kind of operation, addition, multiplication, or whatever it is. So let's run it. See, I'm getting shape 5, comma, D type 64, numpy array having values -4, -2, zeros, 2, 4. The same what I mentioned here. So let's move to third operation, which is called multiplication element wise. Okay, because we are interested to do multiplication, but what is element wise? We will talk about it. Okay, so let me clean this window. Okay, and I will scroll it down first, and I have to teach you about multiplication element wise. Now, what is element wise? We will talk about it. So first, let's perform the operation, and then I will tell you like what is the element wise. Okay. So let me make it a heading, and again I'm using the same value, this x and y. Okay. So I want to do multiplication operation on these two. Okay, these two array, x and y array. Okay, so how can I do this? So simply I have to use tf. There is a function called multiply. You can pass your array, and once you will hit shift enter, you will get some sort of output. And now see, I will tell you what happened. What is a element wise operation? So see, if I will multiply 1 to 5, let me do multiply it here. 1 to 5, I will get 5. If I will multiply these two value, 2 into 4, I will get 8. If I will multiply these two value, 3 into 3, I'll get 9. If I'll multiply these two value, 4 into 2, I will get 8. If I'll multiply these two value, 5 into 1, I'll get 5. So if I'll convert it into a array or tensor, I will simply mention 5, 8, 9, 8, 5. Am I getting somewhere on the screen the same kind of array? So yes, of course we are getting. See, 5, 8, 9, 8, 5. So this is called element wise. Okay, first element of first tensor multiplied to first element of second tensor. This is called element wise multiplication. Similarly, second element of first tensor get multiplied to second element of second tensor. So this is called element wise multiplication. Okay, this is supported by tensor. Okay, so yeah, this is element wise operation. Now let's move to the fourth operation is division element wise. Okay, so division element wise we have to perform now. So let me create one more heading, 4.5 division element wise. Okay, now again, what is element wise? I already explained it to you with an example. Okay, so hope you guys will understand, but let me do the operation once again. I just want to simply perform the operation on these two array or tensor, which I already created. So how can I do this? So I have to use TF because I want to do each and every operation using TensorFlow. That's why I'm using TF all the time. Okay, and I will mention divide is a functionality there. See, there are more than 1,000 operation in TensorFlow, even in NumPy, even in any library. Okay, more than 100 operations are there. So you are not actually memorize all the stuff properly, but you must have some idea like division. If there is some sort of division kind of stuff will happen, definitely there should be division, divide, divisible, some sort of method would be there. So that's why we also guess like I just told you I'm going to divide. Okay, so division, divide, I'm getting divide kind of method here. Okay, so simply I will mention two value x comma y and shift enter, it will give us one tensor. Now what happened? Element wise once again. So element wise, I already told you what is element wise. So now I want to show you if the first element of first tensor get divided by first element of second tensor, it will simply give you some sort of 0.2. Okay. If you are not sure, please use your calculator and divide it. Okay. Similarly, if you divide second element of first tensor with second element of second tensor, you will get 0.5. Similarly, if you divide these two values, you will get 1.0. Okay. I told in the Python, like if you will divide any integer value as well, it will simply give you a floating point value because that's the by default set of Python. Okay. So here 4 divided by 2 will give you 2.0. Okay. 5 divided by 1 will give you 5.1. Okay. So this all value will get in the form of tensor, some sort of this. Now you guys must have gone through this. Okay. And you guys always think about it, what happened with that 0. I said 0 is not mentioned there. Okay. It's by default by the TensorFlow Python. Okay. Whenever you do such kind of division, even in NumPy, you will not get any kind of value over there after point if there is only one value 0. Okay. If you'll get, so let's say here is 1. Okay. Then only you will get 0.1 kind of stuff. All right. Otherwise you will not get anything. Okay. You will get only a dot there. So this is our division operation. Now let's move to next operation. Let me remove this. So matrix multiplication. What is matrix multiplication? We will talk about it. Matrix multiplication. So it is 3.6 matrix multiplication. So I want to do matrix multiplication. Okay. So how matrix work? Basically, I told you what is matrix. Okay. In our school, college, we heard about it. We have seen such kind of matrix. Even last to last video, I guess, I told you about matrix. Okay. So if you have gone through this playlist, you will definitely know about what is matrix. Okay. So matrix means in our school, we used to create matrix like this. Okay. A matrix like this, 2 comma 2, 3 comma 3. Okay. Inside a big bracket, which we are multiplying to another matrix called 4 comma 1, 3 comma 1. I'm just taking random values. If you'll multiply, this is some sort of first row multiply with first column. First row multiply with first column. Then first row again multiply with second column. Some sort of operation happened in our school. Okay, that was matrix multiplication. Okay. So similarly, I'm going to explain you what is matrix multiplication using two such kind of array. Now, in Python or in TensorFlow, matrix are, because we do not have big bracket, right? We do not have such kind of bracket in our Python. So Python can create this array which way? Like how can we create this array in Python or TensorFlow? So we have to simply mention 2 comma 2 like this, a comma, and 3 comma 3 like this. And we do not have big bracket, right? So we will use small bracket on the very first row, and at the end we will put another bracket. So this is same like this one. Okay, there is no difference. Its shape is 2 cross 2 because it has two row, first row, second row, and two column. So this is called column and this is called row. The first value is the identifier of column and the second value is the identifier of row, means how many rows are there, it will tell you. Okay. So similarly, I can create it using a tensor. Okay, like this 4 comma 1 and 3 comma 1. I'll keep it inside a parenthesis or square bracket because we do not have big square bracket. And this shape is also 2 cross 2. Okay. So the first value is the identifier of column and the second value is the identifier of row. Okay. So if we will do some sort of multiplication, we will definitely go through it. So if you want to create some sort of a multiplication, if you want to perform matrix multiplication, you have to create two array first of all, two tensors for first of all, or matrix you can say, all are same. Okay. So I'm creating two matrix same as mentioned in the demonstration. Okay. So let me create a variable k K has a matrix TF dot constant. I'm going to use, you can use variable also, no problem. If there is some sort of changes, but my tensor, I do not have any motive to change my tensor size or shape. So that's why I'm using constant here. You can also use variable. So first of all, I'm going to mention two brackets there inside a big bracket. So these are our big bracket, okay? This is the closing of big bracket. And this is my first small bracket. This is my second small bracket, okay? So I'm going to put 2 comma 2. This is the first 2 comma 2 row, okay? And the second value contain 3 comma 3. 3 comma 3, okay? And let me create both, okay? Sorry, let me create M tensor using constant. And I will mention 4 comma 1 because I used 4 comma 1 in the very first row, and then I have to put it inside a big bracket also. Yeah, then 3 comma 1. Just follow the same like me, you will not get confused, okay? So if you will print the value of K, just to identify whether this is K, I'm putting a value K in front of tensor and M, okay? So M, yep. A comma there. You can use single bracket, double bracket, triple bracket, everything is acceptable here, which I told you. So there are two kind of array we will get. So this is our first tensor K, and this is our second tensor M, okay? This is our second tensor M. So there we are getting all the values same like this. See, 2 comma 2. Let me use my marker to show you. So see, this is the first row of first matrix. So I created same like this. This is second row of first matrix, see, 3 comma 3. And I put them inside a big square bracket. See, similarly here, we have first row of second tensor and second row of second tensor. See, both are same. So now I want to multiply. I'm simply going to erase this, okay? So let's multiply it. So TF dot matmul operation is there. Matmul, matrix multiplication. That's full form is matrix multiplication. Okay, in NumPy also there is matmul. Okay, so you simply have to pass your array. Okay, so I'm passing K comma M. Okay, because I want to multiply these two tensor. Okay, so let's get some idea. Okay, so what do you think? What kind of shape we will get? So I told you, if you want to multiply, okay, see, matrix multiplication always need to fulfill two conditions. First condition is dimension must be same. Means, see, it has two element inside shape. Here we also have two element, 1 2 1 2. That means it is 2D array. This is also 1 2 2D array. Okay, so dimensions are what? Same, because inside this we have two elements. Here we also have two elements. Okay, so we are not talking about specific this number two. Okay, we are talking about this parenthesis. Okay, means how many elements are there inside this parenthesis. So there are two elements. That's mean two dimension. Or if you're not sure like what it is, okay, so you simply have to count the initial bracket. So it has two bracket, 1 and 2. So this is called two dimension array. It also has two brackets, see? So it is also two dimension. So both are two dimension array, you can simply multiply them, okay? So using matmul, you can multiply them. So whatever output, this is the first condition we have to consider about. We have to first check how many dimensions of these two element or those matrix which are coming in the matmul operation, okay? So we have to consider this thing, their dimensions should be same. Okay, if their dimensions are not same, the matrix multiplication is not going to happen. Okay, so the second part is we have considered about, suppose this is a matrix 2 comma 2 3 comma 1. Okay, its shape is 2 comma 2. Okay, and we have one more matrix. Okay, it is little bigger. 2, 2, 3, 4, comma 1, comma 2. So its shape is 2, comma 3. It has 2 row and 3 columns. See, it has 2 row and 3 column. So this is column, this is row. Okay. So 2 row and 3 column. Okay. It has 2 row, 2 row and 2 column. Okay. That's why here it is mentioned 2, comma 2. So always keep in mind these two values, okay, the dimension, the shape of column of first matrix should be equal to the shape of row of second matrix. Okay, if these two are same, then only multiplication is possible. Matrix multiplication. Second, what shape we will get? Okay, so see, here we have two mentioned row in the very first matrix, and here we have 3 column. Okay, so we will get the shape of new matrix in the form of 2, comma 3. Okay, 2, comma 3 means it has 2 row and 3 columns. Okay, so this thing we will get, such kind of matrix we will get. But the current scenario is we have 2 row 2 column in both cases. So first matrix column and second matrix row are equal. Okay, that means multiplication is possible. Now what should be the shape of new matrix, okay, after multiplication? So it would be this 2 multiply 2. So this would be the shape of new matrix. Okay, so let's see, if I will do multiplication, what should I get? See guys, we are getting 1, 4, 4, which is first row, and this is our second. So there are 2 row and 2 column. Okay, so this shape is also 2, comma 2. If you are not sure, here we have shape. See, 2, comma 2. We are getting shape which is equal to 2, comma 2. I also mentioned the same. So this is about it, guys. This is all about TensorFlow matrix multiplication. Okay, about their basic operations. So hope you guys like this video. If you really enjoyed, please give me a thumbs up, subscribe to this channel, share with your friend families, and have a nice day, guys. Thank you very much.